a cheap and surprisingly dysfunctional LED lamp with built-in Bluetooth speaker from eBay. Let me screw this in, but when I screw it in, it is going to go through stroby colour sequences. Just be aware of that, but it's not that bright anyway, so it doesn't really matter. It's more sort of novelty. There we go. This is the remote control that came with it. I pulled the little battery tab out, nothing worked, so I checked the battery was in there, nothing worked. I changed the battery, nothing worked. I found that sometimes it will work and sometimes it won't, but the one button that does work is fade here, which selects fade, but the other ones, like, you can't pick single colours. Fortunately, this completely random, similar looking remote does, if you stagger all the buttons, then this one does do red, green, blue, you don't get white, and it does do the on-off. It also does the effects that it goes through various sequences. But anyway, let's put it to a fixed colour, and I shall play some music and we'll hear how it sounds. One moment, please. And it does work. It has strange audio artifacts at times. And it does, when you select this one, it does seem to pause with strange purring noises and start again. And you can also skip back and forward videos. So that bit of it works. Right, tell you what, I shall stop the music. One moment, please. The music is stopped. Let's remove the speaker. I can't really think of any other things to do with this. Let's try and spudger it open. I assume it just clips together. We shall find out. I shall ram the spudger into it and see if we can make it split apart with loud cracking noise. I assume it's not glued. I see what appears to be a clip here. Well, actually that made a loud crunching noise, so okay. Oh, not bad inside, not bad inside. Quite a big speaker, I have to say. Surprisingly big speaker. And a circuit board that looks multifunction. I'm looking at that little, I'm guessing that this little chip here, well, let me just zoom down this. We'll tell you what, I shall get this circuit board out and take a picture of it, and then we can explore what's on it. One moment, please. Interesting circuit board, not least because it's single-sided. They've done very well to do that. They have cheated at one small point, but it's not bad. It has two connectors in the back. The red one is for power, and the white one is for the speaker. Here is the speaker, and here is the power supply, which is a little semi-isolated module. I shall just short that with my fingers. I'm going to get a shock. I'll get it when I expect it. And it's a 5-volt power supply, although I measured 4.5 volts in the circuit board. I don't know if that was being pulled down by the load of the LEDs. It's not really designed to illuminate a room. This is quite a low power device. The way they've done the LEDs is they're all a parallel array. So if I show you the back of the circuit board, you can see, well, I'll zoom down a bit. You can see that the tracks going to each LED just basically snake backwards and forwards all the way around the LEDs, and there's a start point here and an end point here. And the reason it didn't light white when I used the remote control was because the common positive track, this kind of sawtooth one here, is matched by a negative track on the outside for the missing white LEDs. It turns out that it can either control the RGB LEDs or potentially both, suppose, but also the fairly high power white ones around the outside that are just wired in parallel again. And the transistor for them is here and the resistor is there. I meant to look up what those Y1 transistors are. They're being driven directly from the microcontroller. Makes me think they might be MOSFETs. Not sure. I'm just going to check that right now. One moment, please. Nope, it's not a MOSFET. It's a standard NPN transistor that is being driven directly from the pins these, so they must have some sort of current limiting built in. The chip may well be dedicated purely to controlling lights and controlling the little amplifier with the music. So here's the antenna for the Bluetooth chip, and there's its crystal. The other transistors and resistors for the LEDs, the other colours, are over here. We've got 7.5 ohm, 4.3 ohm, and 5.1 ohm. The supply coming in goes to the chip via a 3.3 ohm resistor, and there's a decoupling capacitor next to it. That's presumably just to provide at least some filtering. The chip then sends a signal over to the amplifier, which is the NS8002A 3-watt amplifier. And this is a 5-volt amplifier, and here's the data sheet for it. I shall zoom down a bit in this. It's a very straightforward amplifier. It seems to be very, very common. It's cheap. It's basically like two high current op amps that can drive the speaker directly. And both the positive inputs to the op amps have a decoupling capacitor to ground, and they also have a divider based on 200k internal resistors that bias those to a midpoint position. The input then has a capacitor and resistor, and that resistor and this negative feedback resistor here will set the gain of the amplifier. I've not really investigated this too much. I did find a data sheet. It was in Chinese. This little arrangement here is to make the other amplifier go in the opposite direction. So when this one's going positive, this one will go negative and vice versa, and it just means it can actually drive, because it can drive the speaker positive, negative, and negative, positive, it gives a much wider voltage range effectively. It makes it louder. It's the equivalent of bridging amplifiers. Very simple. It also, this input here, the SD input, appears to be disabled. And I think it is actually used by the chip, so it can actually mute the amplifier when it's not in use. Is there much else to say about this? The infrared sensor has its own decoupling capacitors over there, as they always do, just because it is a fairly sensitive device. After that, that's it. So power coming on, Bluetooth chip, amplifier, infrared receiver, and LEDs switched by 1, 2, 3 transistors. That is fundamentally it. Something they've done here, which is quite neat, to keep this single-sided circuit board simpler, they've jumped the negative through under the chip. And to do that, they've not put pads down for the pins, or for two of the pins. And what they've actually done is they've printed the black screen print ink on the top in that area just as extra insulation, so the pins of the chip can't actually come in contact with that negative that's passing underneath. It's quite neat. Very neat how they've actually managed to compress it all into that simple design. I don't know what these pads are for, because it might be another design. One of them is connected to positive, the other is just not connected at all. But that's it. It works. It doesn't work that well. It's got its problems, particularly with the remote control. But then again, that's just sometimes what you get. It's certainly an interesting device, and the case is usable. And I suppose the circuitry is relatively usable if you perhaps want to put a bigger speaker on and just use it as a Bluetooth receiver. But it's quite neat. It's okay. It's pretty amazing what they can do with such a small amount of components.